towering 450 feet into the sky, is Western Kentucky Energy's newest chimney. From the outside, it may look like just another concrete structure. However, inside the concrete shell is a crucial 30-foot diameter brick lining. Western Kentucky Energy's chimney liner will require nearly 350,000 bricks, 210,000 pounds of mortar, and the sweat of the bricklayers that put it all together.
Each brick weighs approximately 11 pounds, and each bricklayer lays about 1,000 bricks a day. So during the course of a day, he's lifting approximately 11,000 pounds.
Get you right in here and get you right in here. It just takes a lot of time and practice. I mean, if you do it every day, you get better and better at it. It's kind of exciting being up this high, up in the air. The challenge of the job itself, you can say you've done something at the end of the job, each and every day.
The brick will protect the concrete from the caustic gases exhausted from the daily operation of the power plant.
Older brick chimneys were constructed with outer brick walls and inner brick liners. The outer wall was a common brick or radial brick without acid-resistant qualities.
Concrete has replaced brick on the exterior, but the internal wall still needs to be an acid-resistant material. And here, brick is still king.
The flue gas contains sulfur oxides from the combustion of coal in the boilers. It's cleaned through the use of the flue gas desulfurization system, but what results is a highly saturated flue gas with a sulfuric acid condensate in it, which is highly corrosive to any materials that it comes in contact with. Concrete alone would not be resistant at all to the acid in the flue gas and would start to deteriorate almost immediately.
But the brick used is not just any ordinary brick. It's acid-proof brick. Acid-proof brick is essentially the same brick that we find in our homes. However, it contains a shale clay, a geologically compressed material, which makes it resistant to chemical assaults. But even acid brick is just a brick. To become a brick wall, you need mortar, and in this case, an acid-proof mortar.
The chimney brick is laid in a potassium silicate mortar, which is highly resistant to the sulfuric acid in the flue gas. Ordinary Portland cement mortar would last only a few weeks in this environment.
This mortar is a lot different than regular mortar. You put on a thin layer, whereas when you're laying different brick, you have to lay thicker mortar joints.
With 300 feet of wall left to go, the bricklayers are just starting to feel the burn.
I probably will have laid about 70 or 80,000 brick by the end of this project. It'll be a memory that, will go on forever. Every time I drive by, I say, yeah, I was part of that project.
The history of brick is the story of civilization. And it has been said that architecture itself began when two bricks were put together well. Although many great civilizations have risen and fallen, the narrative of their ingenuity can be found in the brick and mortar structures that defiantly stand against time and the elements. Brick is one of the oldest building materials manufactured by man.
You have bricks they found that are as old as 10,000 years old. So it's been something that, people understood as a technology from the very beginning.
The earliest bricks we find, sort of late Stone Age period, Neolithic period, are simply moulded with the hands into a rough loaf shape and then stacked up to make a house and then covered up with mud daubed on the outside.
The first advancement in brickmaking, the wooden mold, was developed sometime after the Stone Age and was utilized extensively by the ancient Egyptians. With this primitive tool, a single brickmaker gained the ability to mold hundreds of identical rectangular bricks in one day.
If you look at the older bricks, some of the ancient Egyptians or some of the things that happened where brickmaking first occurred, it came about as something that would fit a person's hand. And it was made that way, obviously, for efficiency.
The brick of the ancient Egyptians has changed very little through the years. And the mud brick they used is still in use today and is commonly referred to as adobe. To make adobe brick, mud is mixed with straw to add strength and to control shrinking and cracking. The mixture is put into a mold and shaped. And then the soft brick is set out in the sun to dry. But one drawback to this simple building block is that it can be destroyed by water. So perhaps the greatest innovation in brickmaking was the firing of clay.
Firing the bricks is more difficult than you might think. You can't just put them in a bonfire. That doesn't get them hot enough. You need to fire them at about 950 to 1100 degrees centigrade, which is incredibly hot. If you don't get them hot enough, they are soft and they crumble to dust. If you fire them too much, they just turn into a horrible glassy lump and they're completely useless.
At the correct temperatures, the clay vitrifies or becomes glass and fuses with the sand and other inert material, making the brick rock solid. Firing brick was mastered around 3000 BC by the ancient Mesopotamians using primitive kilns. The ancient Egyptian builders had a plentiful supply of stone for their grand structures and found no need for this more durable fired brick. However, both civilizations explored the use of non-clay mortars, primarily lime, gypsum, and bitumen. These mortars sufficiently held bricks together and helped produce some of the most renowned structures in the world. Yet it was the ancient Romans that allowed brick to be exploited to its fullest potential.
Now, the Romans discovered that if you took volcanic ash and mixed it with lime mortar, you could make a mortar that would dry underwater.
Lime mortar is a simple mixture of burnt limestone that has been ground to a white powder, sand, and water. By introducing volcanic ash, the mixture gains the ability to dry underwater.
This was what we would call a cement. This was hugely advantageous because they could then make harbours that were in the sea, ancient baths, aqueducts, etc.
With the fall of the Roman Empire, the technology of Roman cement was lost, but the art of brickmaking survived. The Middle Ages saw more experimentation with brick, and the introduction of terracotta, a decorative sculpted brick.
There's no difference in medieval terracotta really between something that is a moulded brick and something that's a piece of terracotta.
Through the Middle Ages and into the Renaissance, great achievements in brick, including temples, cathedrals, castles, fortifications, and city walls, could be found everywhere. But it was the Great Fire of London in 1666 that took brick construction to the next level. 17th century London was rambling streets and tight little alleyways, with timber frame buildings all packed closely together. On the evening of September 2nd, 1666, a fire started in the baker shop on Pudding Lane, and it quickly spread to neighboring buildings.
Samuel Pepys, the diarist, records in his diary, on the evening of the first day, he and some friends went into a boat and sat on the river watching it. And he said it was almost like watching the first day of hell, and that Armageddon had arrived.
The Fire of London burnt for 4 days. And in that time it engulfed the whole of the ancient city inside the medieval walls. Remarkably, very few people were hurt, and the city of London was devastated. This was the commercial centre of the whole of England.
It was essential for the future of England that London be rebuilt as quickly as possible. And the task of rebuilding the incinerated city fell into the hands of Sir Christopher Wren.
Sir Christopher Wren started out as an academic, but quickly came to notice in intellectual circles and developed as an architect. That's one of the first really recognizable architects in this country.
Wren was involved in drafting the new building regulations for London. Regulations decreeing that the city should be rebuilt with a fireproof material. Brick was the obvious choice. And just outside London, at Bulmer Bricks, a brickwork specializing in made-to-order bricks for restoration projects, many of the brick-making techniques employed to rebuild London are still in use today. Here, bricks are still made by hand using wooden molds.
And this is the traditional method, basically has been used for centuries. maker takes a piece of clay, rolls it in sand, and the sand is a means of releasing it from the mould. And then he can pick his brick up in the mould, takes a board, and just slips it out onto the board. Resands his mould, back onto his stock, and rolls the next brick. But this is the basic principle that's been used since the time of man.
Once formed, the bricks must be dried.
In summer, we wheel the bricks out here to dry naturally in these open-air hack rows. And we pitch the bricks on these little concrete paths in order that they will be exposed to the sun and air and dry. And out here in the summer, there's about 80,000 bricks drying out here at any one time. In the winter, we're then forced into artificial drying in our drying sheds.
Once the bricks are fully dried, they're brought into the kiln to be fired at temperatures reaching up to 2,000 degrees.
It's called a downdraft kiln because the heat is drawn from 7 fireboxes around the outside into the top of the kiln and then down through the bricks that are stacked here, set in a way that allows the heat to percolate down and out of a flue system in the bottom. 12,000 come in here at any one time. We complete the loading, seal the door, warm it up for 2 days, and then fire for 2 days, cool it for 3 days. So it's a continuous process. Unload as soon as it's cool, and repeat the cycle. We have 7 fires around the outside of the kiln. In a regular process, you go round starting at 1 and going round to 7. The secret is to keep the fires even, depending on when the wind is blowing from the west. You might find fires are burning faster on one side of the kiln than the other. The whole thing is to keep the thing in balance.
By the turn of the 20th century, the demand for brick increased beyond the capacity of this early type of brickwork. Having hit a brick wall, brickmaking was quickly transformed from a handicraft to a mechanized industry. And nowhere would the need for brick be greater than in America's first metropolis, New York City. To make brick, you need lots and lots and lots of clay. But not just any clay will do. You need a special clay, like kaolin clay, which is composed of an aluminosilicate material, essential to making fired brick. But that's not all.
Bricks tend to be made from a mixture of clay and sand or some other inert material. If you use pure clay, potter's clay, then the brick is too large an object, and in the kiln it would shrink and crack and break apart. So mud bricks tend to use about 30% clay, or even less, and terracotta or pottery at the other end might be 75% clay.
Throughout history, brick manufacturers have always located themselves where the clay is. And brick architecture can always be found somewhere nearby. Since the 19th century and into the early 20th century, the architecture of New York was predominantly defined by one material: brick.
Before the introduction of brick, fire was a great danger to Manhattan. Great areas of the city were destroyed in the early 19th century, and by the time that the Charlton Street block was constructed, it was illegal to build in wood.
Fires were always good for the brick industry. Its usefulness in terms of fire resistance is one of the most principal reasons for its success as a building material.
By the turn of the 20th century, New York was experiencing the greatest growth of any city in the world. A growth that fueled the unprecedented demand for brick.
Basically what happens in New York is as the city's population increases, the population moves north. And as the population moves north, they build more houses. Typically in New York during this period, the houses are built on the west side because it was close to the Hudson River waterfront.
The Hudson River provided easy, inexpensive transport of bricks to the growing metropolis. But more importantly, it also provided one of the richest clay deposits in the country to the brickmakers upstream.
The clay deposits stretch over a distance of over 100 miles. They're among the largest such deposits in America. There are breaks in it, but the clay deposit region does extend over a considerable distance, which allowed this tremendous amount of production.
And with a seemingly infinite amount of clay, brick manufacturing became the dominant industry on the Hudson River. By the early 20th century, the Hudson River brick industry boasted over 130 manufacturers. It quickly grew to be the largest brick manufacturing region in the world.
At its zenith, in 1905 and 1906, the Hudson River brick industry manufactured 1.3 billion bricks, which is roughly equivalent to a 40-foot high wall, 12 inches thick, with no door or window openings, stretching from Albany to Buffalo, which is over 300 miles.
But the zenith came at a price. The Hudson Valley clay deposits were plundered, and overzealous mining to satiate the demand for bricks led to tragedy in one Hudson River Valley brickyard town. On the evening of January 8, 1906, the village of Haverstraw, New York, would pay the ultimate price.
The Excelsior and the Gillies brickyards dug too tight into the town and the roadways. They undermined the streets.
An early thaw had defrosted soil and clay beneath the village, causing portions of the town to be swallowed into the clay pit below.
1/3 of the village went down with the cave-in. It all happened in a 6 to 7 block area in a crescent shape.
The landslide resulted in the deaths of 19 people and the destruction of 20 homes. Yet despite the tragedy, the brick industry continued to thrive and industrialize.
Moulding of bricks was actually quite slow to mechanise in Europe, but quite fast to mechanise in the United States, where there was a shortage of labour for brick moulding. The machines worked in two ways. Either they simulated hand moulding, or the clay was extruded through a die and then cut off.
A more fuel-efficient kiln had replaced older intermittent kilns, in which the fire had to be extinguished between firings. It further increased productivity of the brickyards. The Hoffman kiln worked by having a number of kilns side by side and moving hot gases between them. The kiln that was being fired would heat up the next kiln slightly. And by arranging them in a big loop, the kilns could be fired continuously.
Many Hoffman kilns have been fired for 50, 75 years continuously without stopping, and would produce tens of thousands of bricks a day.
Hudson River Valley bricks were primarily face brick or architectural brick and encompassed all applications above the ground. But bricks from other parts of the country with denser clay deposits could be used on the ground as well.
Paving bricks are a very special type of brick that is quite different from building bricks because they are far denser in order to make them resistant to water absorption and to give them much greater strength, which they would be required, or the beating that they would take on the ground.
And the road didn't end there. Industry found uses for a series of specialized bricks, referred to as refractory bricks. Made from high-purity clay, fire clay refractory bricks, which include acid-proof brick, can withstand intense temperatures and were used extensively in furnaces, kilns, and other industrial applications. And brick construction itself was aided by another innovation: Portland cement.
The big change in mortar came about with the development of Portland cement. And what it allowed is for mortar to have a greater compressive strength, so you could fill the voids in the mortar joints between the brick with a thicker joint.
The innovation of Portland cement was patented in 1824 by a bricklayer and mason, Joseph Aspdin. Portland cement contains a pulverized mixture of limestone and clay. It's heated until it almost fuses, and then ground up and mixed with water and sand to create a very strong mortar, making the brick wall even more durable. However, a new building block was gaining dominance in construction: the concrete block, made from Portland cement. When the cement was mixed with larger aggregates and water, it could be precast to form a block or poured in place. When the mixture cured, it became rock hard, creating an inexpensive, accommodating, and durable building material. By the 1930s, the heyday of the great Hudson River brick industry had come to an abrupt end. For Tom Sullivan, who has been hunting old bricks since he was a child, the story of brickmaking in the Great Hudson River Valley is preserved by his collection.
Both my families were involved in the brickyards for over 75 years, and growing up, that's all I ever heard was brickyards. And that moved me on into collecting brick. And the collection might come from just walking along the river where the yards used to be, or maybe a building that was being torn down, or a sidewalk. And then a few other members of the family knew I was collecting, and they would drop a few off occasionally. The thing is, a lot of the brands were unique. And what I collect is brick that have a brand, a name or initial or a symbol on them. That's what makes them unique. If you get a brick like here, W&A, that's Wood and Allison. A brick with raised letters is much older. They really didn't start marking the brands until around 1870. Something like this with the raised letters, that's a rare bird. That's rarity. The most common brick that has what we call a frog, and the idea of the frog came from England. It eliminated some of the material, made the brick lighter, and when you laid the brick down in the cement, it helped to bond the brick better. And they call it a frog. Some of them were spelled backwards. Whoever made the wooden mold, they put the letters in so they could read them, not realizing when they put clay in there, it's going to be reversed. So there's such a variety of brands. Even a brick like Shanky here, part of it's missing, but until I get a whole Shanky brick, I'm going to keep that.
The story of the brickyards can also be found in the brick and mortar structures that once dominated the city.
The legacy of the Hudson River brick industry is right down there in New York. All you have to do is to walk around and keep your eyes open.
All of the skyscrapers, they're steel frame construction. The facade itself was infilled with brick or terracotta. And that didn't change until well into the 1930s. And then we moved towards the steel and glass. Glass curtain wall really doesn't formally come on the scene until the post-war years, after World War II.
Today, the look of New York City and other American cities has become glass, steel, and concrete. But the preferred look of Middle America is still brick and mortar.
Even though, we're comfortable with steel and glass and concrete in an office setting or an industrialized setting, most Americans don't feel particularly comfortable with that in their homes. Many people feel that the modern aesthetic can be a little cool. So when we come home at the end of the night, we're typically, wanting some of that warmth, and brick tends to give us that.
And that desire fuels a demand for the billions of bricks that are sold in the United States every year. And to assure that they wouldn't be a few bricks short of a load, high-tech reinforcements would have to be enlisted to get the job done. In the United States, the brick industry is able to produce over 8 billion bricks in a year. And in order to create this abundance of brick, today's factories have become even more sophisticated.
To make brick in a big amount, you need a big amount of clay. We use over 100,000 tons a year.
The raw earth and clay are put through a grinder to be pulverized before they can be processed into brick. It's at this stage that additives can be introduced to the raw material to alter the color of the brick later in the process.
There are several features in the manufacturing process that affect the color of brick. Primarily, of course, is just the chemicals in the raw materials that are involved. Iron is probably the most common metal or material that's involved in the manufacturing process. It gives brick its characteristic red color that so many people think of. But that color can be modified by adding other chemicals such as manganese to produce a brown-colored brick, or other raw materials without iron in that clay or shale will fire to a buff or a lighter color.
But at this rudimentary stage, the color of the mixture offers little clue as to the color of the final brick. The brown clay mixture enters an industrial blender, referred to as a pug mill. where water is introduced.
It's conveyed down here to the vacuum chamber and down into the extruder below. Inside the extruder is a long screw-like auger that pushes the clay forward under a great force.
The dense clay mixture is extruded through a die where the size of the brick is determined. In addition, core holes or circular cavities inside the column are produced by the die. The advantage to coring bricks is that they fire more uniformly. They also become easier to handle, less expensive to ship, and create a better bond with the mortar when laid.
The bricks coming out of the extruder at a rate at about a ton a minute. The brick are stiff but still soft. They go to a cutter here, the slug cutter, where they're cut into long slugs.
The 65-inch long slugs are moved into position on a conveyor belt and stopped using laser sensors. They're then moved forward into position to be pushed hydraulically through wires to form the final brick shape. And in much less time than it would take to produce one handmade brick, over 50 bricks are formed and ready to be stacked.
This is where we stack the brick on the cars. These bricks are wet. They're stacked by these state-of-the-art robots. Years ago, the bricks were stacked by hand, then evolved to a crude kind of machinery. These are the most modern kind of machines you can get now.
The robots are autonomous and operate without a human controller.
We can stack about 20,000 bricks in an hour.
Kiln cars advance through the factory on tracks. And their next destination? The holding room, where temperatures are kept at nearly 90 degrees, with a 90% relative humidity to keep the bricks from drying prematurely.
We can produce the brick much faster than we can dry or fire it. So we store it in these rooms basically wet to condition it before we put it in the drying ovens. The bricks at this point are still soft enough to break.
The cars are parked here until room becomes available in the dryer.
This is the kiln and dryer control room. Here we monitor the temperatures and pressures in the kiln. The tunnel kiln is basically a 300-foot long oven. You can see on these gauges some of the temperatures as you ramp up through the tunnel. The middle part of the tunnel is the hot part. Right now our maximum temperatures are around 1860 Fahrenheit.
The tunnel kiln is in operation 24 hours a day, 7 days a week. Cars enter the kiln and are pushed forward every half hour by the length of half a car. The bricks move through the middle of the kiln for several hours so that the heat can penetrate the bricks thoroughly. It's here that the aluminosilica clay vitrifies or becomes glass and fuses with the sand and other inert material.
If you fire a brick too hot, it will actually turn to a type of glass and melt. We fire it just to the point of vitrification to where we get the optimum strength and low water absorption. With the particular clay at this factory, that temperature is around 1900 degrees Fahrenheit.
To get the kiln to these temperature extremes, 120 programmable natural gas burners are located on the top and sides of the kiln. They create the inferno inside and determine the environment that each kiln car passes through. If bricks that contain sufficient iron are fired at lower temperatures, they will become a pink color. As the temperatures rise, they become a deep red. At higher temperatures, they become a burgundy or a deep purple color. And in a reducing atmosphere where there is less oxygen used in the firing process, the bricks become a deep black and can have a bluish tinge to them. In just 24 hours from their entry into the tunnel kiln, the bricks are ready to be shipped out.
This is almost the last part of the operation here where they're unloading the bricks from the cars. They put the bricks on the pallets and sort out the few bad ones. Then they'll be wrapped and put into inventory.
This is how it's done at Castaic Brick. But in other factories, robots have already completely taken over these tasks.
We see robots coming into the brick plants. And now it's common for the brick to go from their initial manufacturing process, starting out as the raw material, into packages shipped to the job site without ever being touched by humans. The bricklayer is the first one who actually puts their hands on the brick when they place them in the wall.
But robots won't be replacing bricklayers anytime soon, as you have to be much more than just another brick in the wall to become a bricklayer. In order to create a brick wall, you need a bricklayer.
One of the unique things about construction in general is that each project is different. If you're making widgets in a factory, you're concerned about that process. You know, tomorrow I'm making this widget a little better than I made this widget today. But if you're going to build a construction project, you're setting up a factory right there, and the next one's going to be totally different, the next one totally different. So you need that human touch. You know, we constantly investigate mechanical ways to make a craft worker's life easier. But every time you look at some of these, you come back to the most efficient way to lay a brick is by hand with a trowel.
Today, the Bricklayers Union offers a challenging training course for the newest generation entering the trowel trades. Here, students work, eat, and sleep on campus. And for 12 weeks, brick becomes their life.
We have nice places to stay. You got barracks, you got chow hall that provides your food. And I enjoy it. I don't mind. I like it.
The typical training day is from 7:30 a.m. to 4 p.m. And the curriculum is intense.
And once you get here, they teach you all the basics to brickwork. They show you about the mortar and different types of brick and different kinds of bond that you use.
A bond is the arrangement of bricks in a pattern intended to increase the strength or just enhance the appearance of a wall.
This is an English bond, and what we have is alternating courses of stretchers and then headers. It's a very strong bond. It's strong mostly because this header ties this wall together. This is a similar bond. It's a Flemish bond, also a very strong bond, and very decorative. And what we have here is a header, stretcher, header, stretcher, and then they alternate on the next course, so your header is in the center of your stretcher.
But it doesn't stop there. Students learn everything from constructing an arch, cutting masonry units, building piers, and laying refractory products. That is in addition to setting a line, furrowing the mortar, laying a course, and tooling a joint.
It is pretty serious. We're here all day long, except for a 30-minute lunch. That's it. Other than that, we're in here, and we're always on something. As soon as we finish a project, we take it down, and we start another project. And we just keep moving on and keep moving on and just keep progressing and progressing.
Because, of course, it's tougher than it looks to lay a course.
If someone was to tell me, oh, that's easy, I could do that, I'd give them the trowel and give them the mud, say, here you go. Go ahead and do it. And I'd laugh at them. Because it's not that easy. I mean, it looks easy, and I thought it was easy when I first saw it done. It's a lot of hard work.
The program is just a starting point for aspiring bricklayers before they enter the real world, where bricklayers have been building brick walls for countless generations. At first glance, their walls may look similar, but they too have evolved.
It's kind of funny that things didn't change for a long time in brick. You know, you looked at older structures, there's big, thick stone or brick walls, and then as you move through the 19th century, we got to a pinnacle would be the Monadnock building in Chicago.
The Monadnock marks the last of the brick load-bearing wall structures, and it exhibits the problem with all such structures. The walls need to be very thick. In fact, at the base of the Monadnock building, they're over 6 foot thick, and that the building itself becomes very heavy, so heavy in the case of the Monadnock building that it actually sank into the pavement and you have to step down into it. Thereafter, it's realized that tall buildings can no longer be constructed with brick load-bearing walls.
A load-bearing wall consists of bricks laid several thicknesses deep. The bricks below support the entire structure of brick and mortar above it. With the advent of reinforced concrete and steel framing, the reinforced concrete or steel frames support the weight of the building, and bricks become relegated to a veneer.
You don't have these huge mass walls that we had, 100 years ago or before that. You have more of a thin wall system, which might just be one thickness of brick or one width of brick with that airspace and with the concrete block for the structure.
And even though today's brick walls may no longer be the workhorses they once were, they're not wallpaper either. They provide a durable barrier from the wrath of Mother Nature.
This past year, we decided to do some testing to show how good brick was in resisting wind-borne missiles. Hurricanes, of course, can generate a lot of debris that flies through the air, and that debris can damage siding materials. There are standards that have been developed to evaluate the performance of siding materials in protecting the occupants of buildings. We used a fiber cement board, we used vinyl siding, and we used standard face brick as the exterior. That 9-pound missile at 34 miles per hour easily pierced the fiber cement board siding, through the insulation and through the drywall, and projected about 5 feet into the occupied space. That same thing occurred with the vinyl siding. That 8-foot 2x4 simply bounced off the surface of the brick wall, and that passed the test.
Hurricanes may be no match for the mighty brick wall, but other forces of nature can bring it tumbling down. And with smart bricks entering the picture, being thick as a brick may no longer apply. Tuesday, October 17th, 1989. Without warning, a massive earthquake measuring 6.9 on the Richter scale strikes San Francisco, California.
Prepare yourselves! Shut off the gas, shut off electricity, prepare for aftershocks. Make sure your building is sound enough to go back inside.
It lasts only 15 seconds, but leaves parts of the city in ruins. Tons of bricks rain down upon the streets during the evening rush hour, some hitting pedestrians. In the aftermath of the quake, San Francisco was determined to retrofit its over 2,000 unreinforced masonry structures.
The result of the Loma Prieta earthquake in 1989 was a citywide ordinance requiring that all unreinforced masonry buildings be seismically strengthened. The Woolen Mill building, being built in 1864, obviously put it into that category of being unreinforced masonry and was going to be one of the buildings that we would need to strengthen here at Ghirardelli Square.
The buildings which we're particularly concerned with are known as UMBs, which is unreinforced masonry bearing wall buildings. And the reason they're the worst case is because, by definition, the bearing wall is the one that holds the structure up. If the bearing wall fails, then the whole structure can come down, and that will be catastrophic.
Engineers use several methods to seismically upgrade unreinforced buildings.
Conventionally, a lot of buildings have been done with steel bracing. People started doing that, I guess, 20, 30 years ago. There have been a lot of buildings done with shotcrete, which is where they literally spray concrete, and that provides additional strength. More recently, people have been looking for less intrusive ways of strengthening these buildings.
And the latest technological advancement in seismic retrofitting is an epoxy fiber wrap composite. The procedure strengthens brick walls by coating them with thin layers of fiberglass fabric and epoxy. The composite penetrates the brick and mortar and bonds them tightly together. It also provides tensile strength, which allows the normally rigid wall to bend without breaking apart. Ghirardelli's Woolen Mill building is the proving ground for this new technology.
The fiberglass is applied with rolls of fiberglass fabric and then is hardened via an epoxy application. The fiberglass still is part of an overall composite system, which includes steel horizontal members that are bolted into the strengthened wall. On the lower floors, the fiberglass encompasses the entire wall of brick, but as we move up through the building, the need for the fiberglass decreases. As you see, we have a narrow strip of the fiberglass adjacent to the windows. The windows are the weakest point of the building, where we have perimeter openings in the brick wall itself.
Being one of the first to utilize this revolutionary system in San Francisco, the Woolen Mill retrofit is opening doors for this new technology.
Ghirardelli Square has a number of buildings on the property, some of which still need to be seismically strengthened. This was the first unreinforced masonry building to be strengthened, and we will look at the technologies used here as we make decisions going forward to seismically strengthen the other buildings.
I think it'll find more widespread use than it has at the moment. I think as systems go, it works very well, and it certainly helps the buildings in their behaviour. Unlike the steel frames or the concrete, which tends to fight against the brickwork, it actually works with it. That makes it very appealing.
Today's epoxy fiber wrap composites may be the salvation for unreinforced brick buildings when the next big one hits. And in the future, smart brick technology developed at the Micro Actuators, Sensors and Systems Group at the University of Illinois Urbana-Champaign may assist engineers to locate structural weaknesses afterwards.
One recent technique that was developed is the embedment of a computer chip into brick, which is then placed into the building. These smart brick can provide information on the temperature variations that the brick is going through, what type of vibration might be coming as a result of wind load or other loadings on the building itself. They can provide information that might indicate deterioration of the wall assembly, buildup of moisture, things of that nature. So the brick serves as a means to provide those sensors, those chips, into the building so that the engineers can analyze the data that they're able to collect from that source.
Several embedded bricks at different locations around the building would form a network and submit information wirelessly to a remote computer. These high-tech bricks cap a legacy thousands of years in the making. It's just burnt clay, but it has shaped our world. And it's no wonder that we have developed a love affair with this seemingly humble material.
From when we're young children, we play with bricks and blocks, and we learn about the three little pigs and how that last house made of brick couldn't huff or puff or blow that house down. So brick is always part of our culture. You follow the yellow brick road, you follow your dreams.
It may have a very long history, but it's a history of mass production. So the brick is, if we like, stands for the modern age. What it shows us is that modern isn't nearly as modern as we think.
I see no reason why man should stop using a brick. In fact, it might come back in as we have to husband our resources more. It might in fact become more important than it is at the present time.